Hey everybody, so in this video we're going to be looking at some optimization word problems that we're going to be solved by graphing. So let's look at example 1. You need to buy some filing cabinets. You know that cabinet X costs $10 per unit, requires 6 square feet of floor space, and holds 8 cubic feet of files. Cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. You've been given $140 for this purchase, though you don't have to spend that much. The office has room for no more than 72 square feet of cabinets. How many of which model should you buy in order to maximize storage volume? So for this first one, we're just going to take it one step at a time. We're going to go through each kind of phase of what we're going to be doing. In the next examples, it's not going to spell it out for you quite as much, but for this first one, it's going to give you everything you need. So, part A. What are we going to have our variables be? All right. Well, what do we want to know? We want to know how many of which model should you buy. All right, so let X be the number of cabinet X, and let Y be the number of cabinet Y. Okay. Now, would it make sense to say that you're going to buy negative 10 filing cabinets? No, it can't be negative. So, in order to make sure that we don't have any negatives, we're going to put two inequalities. X is greater than or equal to 0, and Y is greater than or equal to 0. Alright, part B. Since the office has a capacity of 72 square feet, write an inequality to represent the situation. Alright, so the key here is that we're looking for square feet. Alright, where else do we see square feet? Well, we see 6 square feet right there. We see 8 square feet, and then the 72. Alright. So, we know that cabinet X needs the 6 square feet. So 6 times the number of cabinet X, which is just X, plus cabinet Y requires 8 square feet. So 8 times cabinet Y, which is just Y. Right? And that has to be less than or equal to 72 square feet. Right? It doesn't actually need to be equal, because it's fine if you have less than that, right? It just means more walking around room. So that's perfect. We just can't have more than that. That's the important part. All right, part C. Since you have been given $140, write an inequality to represent the situation. All right, this time we're talking about money. All right, so where else do we see money? Cabinet X is $10 per unit. Cabinet Y is $20 per unit. And then we have $140 to spend. All right, so it's $10 per cabinet X plus $20 per cabinet Y. And again, I'm pretty sure that your boss wouldn't get mad at you for spending less money than you were budgeted. They'd probably be happy about that, right? So that just needs to be less than or equal to 140. Doesn't have to be equal, because you don't have to spend 140. You just can't spend more than that, because your boss would get mad if you go asking for more money. All right, part D. Write an equation for the volume. So volume is anytime it says cubic feet. So let's look at where all it says cubic feet. So we know cabinet X holds 8 cubic feet. Cabinet Y holds 12 cubic feet. And we don't have anything that's less than or equal to because we're just trying to maximize that, right? So for this one, I'm just going to say Z equals 8x, because 8 cubic feet per X cabinet, plus 12y. All right, that one is going to be equal because that's the one we're actually trying to maximize. We want the most volume we can get. All right, so the setup for these is extremely similar to when we did the other matrix word problems. The main difference is now instead of equals, it's less than or equal to. All right, time to start graphing. So first off, just so nobody forgets, we do have those x is greater than or equal to 0 and y is greater than or equal to 0. So all that means is the x and y axis are actually constraints, all right? So it means we have to be somewhere up here. All right, can't be over that way, can't be underneath, has to be up in this first quadrant. All right, next up, we had 6x plus 8y less than or equal to 72. All right, so in order to do this, we can just solve for y. So to solve for y, we subtract 6x from both sides. Oops, let me go back to this. Subtract 6x from both sides. Get 8y is less than or equal to negative 6x plus 72. Divide both sides by 8. So we get y is less than or equal to, if we simplify it, it's going to be negative 3/4 x plus 9. All right? So to graph this, first we go up 9. So right here. Then the slope is negative 3/4, so that means we go down 3 over 4. Down 3 over 4. That will get us our first line. All right, and actually let me make this a little bit straighter. So for these, you really do want to make it as straight as humanly possible. It's just like whenever we're graphing to solve systems, we're going to need to know where this stuff crosses. So it's a good idea to go ahead and graph it as straight as humanly possible. All right, that's better. All right. So now we're going to graph the second one. So the second one was 10x plus 20y less than or equal to 140. So if we subtract 10x from both sides, we get 20y is less than or equal to negative 10x plus 140. Then we can divide both sides by 20, and we get y is less than or equal to negative 1/2 x plus 7. So again, in order to graph this one, we're going to go up 7, put our first point, and then it's going to be down 1 over 2. Down 1 over 2. Over and over. And again, draw our line. and we're good to go with that one. All right. So there's still one thing we need to do for this though. We need to shade. All right. So in order to shade, we have to look at the inequality symbols. Now in this case, it's a little bit easier because both of them are less than or equal to. Anytime you see the whole system of inequalities have less than or equal to, then that always means you're going to shade in the corner. All right, so if I just shade over here, that's our little region. All right, so let's look at F. Use the corner points to find the maximum volume. All right, so first off, if we're going to use the corner points, we need to find those corner points. So the corner points are just the edge of our shaded region. All right, so right now our shaded region, its boundaries are right here. So we're just going to look at what are the corners of that shape. So we have 0, 0. We have 0, 7. We have 8, 3. And lastly, 12, 0. All right. So in order to find what the maximum value is, we need to actually put this into a little chart. All right. So I'm just gonna have a little chart over here that has our points, and then it has the equation we're actually wanting to maximize, which is this 8x plus 12y. So our points are 0, 0, 0, 7, 8, 3, 12, 0. All right. So 0, 0 is easy, because if we plug in 0 for each, then the zeros just all go away, and so we have 0. For 0, 7, we're going to have 8 times 0 plus 12 times 7. So if we do that, we get 84. Next up, we have 8 times 8 plus 12 times 3. If we do that, we're going to end up with 100. So it would just be 64 plus 36. And lastly, 8 times 12 plus 12 times 0. So add that up and we're going to get 96. So what is our maximum? It's just going to be the one that gives the highest number. All right, so this whole row is what we're looking at. All right, so for part G, how many types of each filing cabinet are needed to maximize the volume? So we need, for cabinet X, we need 8 of them. For cabinet Y, we need 3 of them. That was just from our point. That's what gets us to our maximum. The maximum volume is the 100. All right? And since it's volume, it's 100 cubic feet. Okay? And that's it for this first one. I'm going to try to not make these videos, an hour long. So that's going to be it for this one. And the other two will have their own videos. So I will see you guys in the next video.